Hello, welcome to my channel. Now it is still October 18th of 2024. I just did another video before this. I was confused at the end about what I was trying to do. But what I'm trying to do is I'm using a 12 volt automotive battery and I'm going to create more voltage at these two-prong plugs. You know, if there's 12 volts going in, there's going to be 12 volts on one plug and one at the other plug. And then what you do is connect an AC to DC voltage doubler to create 24 volts each at the outputs. Then you can use those to drop them down to 12 volts again using DC voltage dividers. And that would give you you'd have four sources of 12 volts to feed into four inverters. Or you can just use, put a pair in parallel with each other, and then you have more current going into two inverters. So I'm going to turn this on so the light bulbs come on, and I'll test the voltage. And it's going to be about 7.5 volts because I'm using this 10-to-1 step down transformer that puts out about 15 volts AC because it's connected to this inverter which puts out 120 volts AC, which is connected to the 12 volt battery, which actually puts out about 14 or 15 volts. Well, 13 or 14 volts, and this transformer puts out about 15 volts AC because it is meant for 115 volts AC, not 120 volts. Some states or countries must use 115 volts AC in their supply to their customers. So, okay, I'll turn this on, and then I'll talk about the current measurements I got written down here. So there's light bulbs on, and I just got to turn on this meter, and the red one measures, hard to see it, there it is, 7.4 up to 7.45 volts. And so we can assume the black one has about the same. I'm just using the two capacitors instead of 3 or 4, plus the two diodes. So I can turn it off now. And I don't think we can call this a power supply current saver though, because here's the measurements I made. The current going out into the load device, which is the little light bulb, is 0.15 because we got two light bulbs. You just times that by 2 is 0.3 amps. And the current coming current coming out of the transformer secondary is 1.28 amps, which is a whole lot more. And the current going into the primary coils of the transformer is 0.31 amps. So I don't know where this 1.28 current is going. It's charging the capacitors up. And maybe they're discharging back into the secondary. That's why it's got a lot more current. So I don't know if it's the same current or not, but at least you got more voltage. Or maybe that's how much current is available, because a step-down transformer puts out more current than it takes in to the primary coil. But it should be about 10 times, 9 or 10 times more. No, it wouldn't be enough. And when I did the other transformer, this one here is a 5-to-1 step down, but I can't use that much anymore. It's damaged and heats up. I measured up here. The current going into the load device was 1.6. Since there's two devices, 0.32 amps. And 1.72 coming out of the transformer and 0.46 going in. So, I don't know, we're going to have to be hard. It's going to be difficult to determine if it's saving any current. I suppose maybe what I could do is measure the current coming out of the battery. Maybe I could do that right now. It wouldn't take long here. And compare it. What's coming out of the load. That's DC though. Excuse me. DC. Okay, so it measures what? Oh, it's not turned on for one thing. That don't help. Okay, there's the bulbs on. Now, it should measure something. Oh, look at that. 1.58. 1.6. Okay, I'll just check the black wire too. It's about the same, yeah. So now compare that with yeah, 1.28 coming out of the transformer. That's AC though. Okay, so I don't know if that's going to help anything. Turn it off. Okay. Well, pros, get more voltage. Because this video is about another part of how to get more voltage out of a battery or solar cell, etc. Okay, thanks so much for watching. Goodbye.